Hello, I'm Luis Serrano and this is Serrano Academy. And this video is about decision trees. Decision trees are one of the most popular machine learning models out there. And the reason is, first of all, they work really well in real life, and second of all, they're very intuitive. See, the way decision trees make predictions is very similar to the way we actually make decisions ourselves. So let me show you how they work with one of my favorite examples, recommendation systems. So this video is actually linked to this blog post about decision trees, which I invite you to check out if you'd like to see what we see on this video, but more in detail with the math all worked out. So this is how decision trees work. Let's say it's the morning and you'd like to decide if you should wear a jacket or not. So what's the rationale? Well, one thing you can do is look through the window and check if it's raining or not. If it's raining, then you definitely wear a jacket. But what if it isn't raining? Well, then there's still a decision to take. For example, you can check out the temperature and decide that if it's cold outside, then you will still wear a jacket, but that if it's warm, then you won't wear a jacket. What you just built is a decision tree, where every decision becomes a node, and each of the options to take becomes an edge to a new node or to a final decision. Now, there are many decision trees you can use to decide if you wear a jacket or not. For example, here's another one, in which you check if it's Monday, if your car is red, and if you drank coffee today. Now here's an easy question. Which of these two decision trees is better? Well, it seems like the second one is not very good, but the first one is. And there may even be a better one, but from these, the best one is the first one. And this is because the second one may be wrong many times, as it has nodes that have no relation to wearing a jacket or not, whereas the first one seems to work well most of the time. So that's how decision tree works. And the role of machine learning is to help us find the best decision tree we can for a particular question. Or more specifically, given some data, machine learning will help us find the decision tree that fits the data in the best possible way. Let me show you with an example. So let's start by looking at a small data set. This over here is a recommendations data set, and the idea is that we are the App Store or the Google Play Store, and we'd like to recommend apps to users based on their demographics. So we look at our data set of users, which has 3 columns: gender, age, and the app they downloaded. And for simplicity, let's assume that the small data set only has 2 genders, male and female, and a few ages, and the apps they can download are TikTok, YouTube, and Facebook. And based on this data set, we'd like to formulate a rule that helps us recommend apps for future users. So the data set has 6 users, their gender, age, and the app they downloaded. From here, can you spot any trends? So I invite you to pause this video for a minute and try to figure out, for example, what app would you recommend to a user which is a 16-year-old female? Now feel free to pause this video and try to figure it out yourself. And if you said that you would recommend TikTok, then you were right. And that's exactly what I would recommend. Why? Well, because if you look at all the young people in the data set, then they all seem to download TikTok. So it's a fair bet to say that this 16-year-old will probably download TikTok. Now here's another exercise. What app would you recommend to a female who is 30 years old? Well, again, if you look at the females in the data set around those ages, this one have ages 25 and 35, they both downloaded YouTube. So it's fair to say that this 30-year-old female is likely to download YouTube as well. And finally, we got this 35-year-old male. What would you recommend to him? Well, given that the closest person in the data set is a 32-year-old male and he downloaded Facebook, then we can say with some confidence that it's good to recommend Facebook to this user. Now, the idea behind decision trees is to add math to the whole reasoning we did here. Why would we want to add math? Because imagine if this table had, instead of 3 columns and 6 rows, thousands and thousands of columns and rows. You wouldn't be able to eyeball these relations as easy as you did here. And instead you'd have to rely on formulas and math. And that math has a name: decision trees. And luckily, the intuition behind the math and what you just did to recommend apps to these users are exactly the same. So before we tackle the whole data set, let's do the same process but with a small simplification. Let's label anyone who's under 20 as young and anyone who's 20 and over as adult. We'll do the math in this data set, but after that I'll show you how to do it in the original data set, and you'll see the difference between the two methods is very small. Now what we'll do is we'll study the 2 features, gender and age, and figure out which one of the 2 is more important in determining the apps the users download. So let's split them like this in order to study them. Now, which one do you think it'll be? Gender or age? Feel free to pause the video and think about it yourself. This is the most important step in building a decision tree. And the question is, which of the two features, gender or age, is more determining on the app the users downloaded? So let's look at the first one, which is gender. But in order to understand it better, let's actually split them by gender. So let's actually put the females in the top of the table and the males at the bottom. And now let's plot this in a small decision tree, which we're going to call a decision stump, since it's simply a tree stump with some branches coming off of it. And in this stump, let's put the females on the left with the apps they downloaded and the males on the right. So this is called the gender decision stump, and we're going to get to it later. Now let's do a splitting but by age. So let's organize the young people in the top of the table and the adults on the bottom. And again, let's make an age decision stump and put the apps they downloaded on the left for the young ones and on the right for the adult ones. And now we simply need to compare these two decision stumps, the gender one and the age one, to see which one is better. Now, from looking at them, which one does your intuition tell you is better? So there are several ways to measure them, but my money is on the age one. So let's see. The question I like to ask myself when I try to decide which decision stump is better is the following. If my entire recommendation system was this decision stump, then which one of the two would be better? So let's try to build the best possible recommendation system for each one of the stumps. So for the one on the left, say, what would you recommend to the females on the tree on the left? Well, it seems that the best recommendation to give them is YouTube, right? Because this recommendation would be right 2 out of 3 times. In general, we always pick the majority. If there are ties, then we select each one at random. But here it's clear that more people downloaded YouTube, so let's recommend them YouTube. Now, what do we recommend to the males? Well, it seems like TikTok is the way to go because it's the one that the majority downloaded. Now let's go to the age decision stump. What would you recommend to the young people? Well, this one's pretty clear. It's gotta be TikTok because everyone downloaded TikTok. And for the adults, it seems like YouTube is the winner because 2 out of 3 downloaded YouTube. And now the question is, how many times was each one of them correct? Well, this one over here, the females, was correct 2 out of 3 times because it recommended YouTube to the people who downloaded YouTube. For the males, again, 2 out of 3 were correct. So this classifier is correct 4 times and wrong 2 times. And the age one, well, among the young people, it was correct 3 times. And among the adults, it was correct twice for the 2 YouTube users. So this one was correct 5 times and wrong 1 time. So this one wins. So the age decision stump is definitely better. Now, the metric you use here to determine what split or what feature was better is accuracy. So notice that the classifier on the left has an accuracy of 4/6, which is also 2/3, since it's correct 4 times out of 6. And the classifier on the right has an accuracy of 5/6, and it is correct 5 times out of 6. And once we do the first split, that's actually the hardest part because all we have to do now is to iterate. So now we have 2 small data sets, the one on the left, no, the young ones, and the one on the right, which are the adults. And the one on the left node is already perfectly classified, as recommending TikTok to all these users will get us a classifier with 100% accuracy. So we don't have to worry about that one. For the one on the right, for the adults, there's more we can do. See, if you look carefully at the small data set of adults, you may notice that there's not a lot more we can do with the age feature, but using the gender feature, we can split these sets pretty well. See, when you look at the 2 who downloaded YouTube are females and the one who downloaded Facebook was male. That means that if we now split this small data set by gender, then we're going to have a perfect split because the 2 on the left downloaded YouTube and the one on the right downloaded Facebook. Therefore, all we have to do is add this gender node here and have the split among the adults. And then we end up with a nice version of the tree. Here's how the tree works in order to make predictions. Let's bring back the users we tested at the beginning and see what the decision tree model would recommend to them. The first one was a 16-year-old female, so this user goes into the tree and moves left as the age is young, and then the model recommends her TikTok. The second one was a 30-year-old female, so in the age node she goes to the right as she's an adult, and then in the gender node she goes to the left as she's female. And the model recommends her YouTube. And finally, we got a 35-year-old man. This user goes to the right on the age node as he's an adult, and to the right on the gender node as he's male. Therefore, the model recommends him Facebook. And that's how it works for every possible user. Now, note that this tree works really well in the existing dataset. Now, in real life, this may be correct sometimes and wrong other times, but the important thing is that for this particular dataset, it did very well. Now, before I show you some general information about building larger trees, remember that we turned the age column into a young and old column? What we did is we took numerical data and a bunch of numbers and turned it into categorical data, which is 2 or more categories. But decision trees can still be trained on numerical data like this. In other words, if the age column had numbers instead of categories, we can still figure out what the best split is. It takes a little bit more work as we have to figure out what's a good number to split the age. But here's how we do it. Let's put all the ages on a line over here and with the apps they have downloaded. So some of these cuts between two numbers should be ideal, right? One of these ones. Now let's simply test them all and see which one wins. So let's start with the first split. That's somewhere between 12 and 14. So for simplicity, let's say we cut at 13, but it doesn't really matter where we cut. So what happens when we cut at 13? Well, we get this decision stump here, because on the under 13 category, we only have one user, which is the one that downloaded TikTok. And on the 13 and over side, we have 5 users. Now, what we recommend to the users on each side? Well, on the left, it's clear that we should recommend TikTok. And on the right, well, you can recommend YouTube or TikTok, as both gives us just as good a result. And so what's the accuracy of this recommender? In other words, how many times is it correct on the data set? Well, here it's correct once on the under 13 category and twice under 13 and over category for the YouTube ones. So it's correct 3 times. And remember that we could have just as easily recommended TikTok instead, and the 2 corrections would have been these 2, but you still get 3 correct. So the accuracy of the classifier by cutting at age 13 is 3. Now let's look at the next one, cutting between 14 and 15. So for simplicity, let's say we cut at 14.5. That gives us this decision stump here, where at the left we can recommend TikTok and on the right we can recommend YouTube, which is the most popular one. This one is correct twice here and twice here, which is 4. So that's correct 4 times. Now let's continue. The classifier, where it cuts the age between 15 and 25. So for simplicity, let's say it cuts at 20. That one's similar to the one we've seen before. We recommend TikTok to the ones on the left, YouTube to the ones on the right, and we are correct a total of 5 times. So that one's pretty good. But let's continue. The one between 25 and 32, let's say we cut at 28.5, and this one recommends TikTok for the left and YouTube for the right, and it's correct a total of 4 times. And finally, the final split between 32 and 35, let's say we cut at 33.5, and this one gives us this split where we recommend TikTok for the left, YouTube for the right, and we are correct 4 times. So this one is correct 4 times. And so which one wins? Well, the one that's correct 5 times is the best one. And recall that this is the one that cut the age at 20, and to the users that are younger than 20, it recommended TikTok, and to the ones that are 20 or older, recommended YouTube. And just like before, we have the split, and then we do a second split by gender, which helps us continue building the tree. And just like before, we have a bunch of nodes and a bunch of leaves. Leaves are the final nodes of the tree where there's nothing underneath, and those are the ones that correspond to a recommendation. Now we managed to build a small tree for a dataset of 6 rows and 3 columns. What happens with a big dataset with lots and lots of rows and columns? Well, it's actually the same thing. Among the columns, we have to look for the best split. So what we mean is the feature that's most determining of the actual recommendation. So we're looking at, of all the decision tree stumps, which one gives us the best accuracy. So let's say that we do this and we find out that age is the best split. So then we split the data set into two, and then we iterate. And now let's say that for the left one, the best split is country where they live. And for the right one, the best split is by how many likes they have. And so on and so forth. So we can continue this process, splitting and splitting, until we get a place where we're happy. And that's how we build a decision tree. Now the question is where to stop, because there can be small problems if we never stop building the tree. So let's say if we continue splitting the data and then splitting it more and more and more and more, then we have a tree so large that the leaves only have one or very few data points. And what we did here is we didn't learn the data, but we memorized it. So predictions can be really specific. Let's say that if a user has a certain age, a certain particular gender, a particular country, if they watch these few videos and like these others and have these subscribers, etc., then we recommend them a certain app. However, that doesn't generalize well to new users. It just simply memorizes the ones they already have. So it's basically like memorizing exam questions instead of learning the material. You may be able to answer any question that you already seen in the book, but you won't be able to answer questions that are different from those. And the idea of a recommender is to be able to recommend to new users. The idea of a machine learning model is that should be able to make predictions in points that it hasn't seen based on the points that it's already seen. So it has to learn, and it can't just memorize a bunch of points. Memorizing is a big problem in machine learning called overfitting. It's a very common problem, and if you'd like to learn a bunch of techniques on how to prevent overfitting or memorizing, check out this video in my channel, which is called Machine Learning Testing and Error Metrics. So here are some heuristics to prevent overfitting, and there are artificial ways to stop splitting a node. Imagine this, that the data coming to a node after building it for several levels has these labels, 3 YouTube users and 1 Facebook user. And then you manage to split with a particular feature and get the 3 YouTube users on the left and the 1 Facebook user on the right. Now this split is a bit strange because it left a node with only 1 data point, so there's too few samples in this node. So let's actually hard code a line of code that prevents the split if one of the nodes has very few data points, or if the split is too uneven. Another criteria is the following. Let's say that for this recommender, we recommend YouTube to the users along the left and Facebook to the one on the right, so we're correct the 4 times. But if we were to remove this split and recommend YouTube here, we would be correct 3 out of 4 times. And now it's okay to sacrifice a little bit of accuracy to have a tree that is less deep, because deep trees tend to overfit more. So if we don't see a huge increase in accuracy, then we're not going to split a node. We can also say, let's stop splitting after a certain depth. For example, 4 levels or 10 levels or 20 levels. That's actually a good way to make sure the tree is not too deep. And there are many other heuristics used to stop splitting trees and to actually prevent overfitting. Now here's a question. To build this decision tree, we used accuracy of the split. Is that the only way to do it? Actually, no. There's lots of ways of splitting nodes. So one of them is using the Gini impurity index, another one is using information gain and Shannon entropy. So we won't discuss them here in detail, but if you'd like to learn what they are, feel free to check out these other videos I have on the channel on these topics. And how do we use Gini index or entropy to split the node? Well, in a very similar way to accuracy. Remember that over here we're deciding which feature between gender and age was better to split the node. So for this, let's calculate the Gini index of each of the nodes as a set with labels. So the Gini index is a measure of how diverse is a data set. So a data set is pure, that is one in which all the labels are the same, has a Gini index of 0. And a data set in which all the labels are completely different has a very large Gini index. So for example, this one over here, the Gini index is 0.444, and same thing for the other one. And so the average Gini index for the split is 0.444. It's the average of those 2 numbers. For the age decision stump, this side over here has Gini index of 0 because it's a pure data set. All the labels are the same. And this one over here has a Gini index of 0.444. So the average is 0.222. And therefore this one wins because we want the smallest Gini index on average. And the reason for this is that we want our split to be as pure as possible. If you manage to put all the same labels on one side, then you win. or as close as you can. Now with entropy is very similar, because entropy is another measure of purity in a data set. So the one on the left has an entropy of 0.918, and the same thing for this one over here. So the average entropy is 0.918. The entropy of this node over here is again 0 because it's a pure data set. This one is 0.918, so the average is 0.459. And so again, the decision tree on the right was the one who won, and age is a better feature because it had a smaller average entropy on the split. Now this is very interesting because accuracy, Gini index, and entropy all yield the same decision stump, the same feature. They all said that age won. This is not always the case. Sometimes they won't match answers, but most of the time when a feature is good, it wins on the 3 metrics. So that's all, folks. I hope you enjoyed the video, and I remind you that if you would like to see this reasoning more in detail, please check out this blog post on Medium. The link is in the comments. It's actually the same data set, just a few small changes, and the same math, and as I said, the math is in a lot more detail there. And this is actually a chapter in my book, Grokking Machine Learning. There's an entire chapter of decision trees which goes into a lot more detail. Then it has random forest, XGBoost, all kind of extensions of decision trees that work really well. So I encourage you to take a look at the book. And there's actually, the link is right here, and there's a 40% discount code for anyone from this channel who would like to buy it, and the discount code is SerranoYP. The link for the book is underneath this video in the comments. So thank you very much. If you like this video, I will invite you to subscribe to the channel for more content. Also, please hit like, share it, and throw in a comment. I love to read comments. If you have any ideas for future videos, please put them there. So I really enjoy reading the comments. And you can also tweet at me. My Twitter handle is LuisLikesMath. And if you'd like to view all these videos and all the information in my page with blog posts, etc., check out serrano.academy. So that's all for now. Thank you for your attention, and see you in the next video.